All right, now let's see if we can use the ideas we've been developing to actually prove another theorem. So here's the theorem I want us to look at. So the hypothesis, the given, is that the segment AE is congruent to EC. So now I'm going to mark this up as I read through it. So AE, that segment right there, is congruent to EC. So this is congruent to this. BE is congruent to ED. So this length is congruent to that. These lengths are equal, these sides are congruent. And now the mission is to prove that AB is congruent to DC. How can we do it? Well, it seems like these sides are sort of way off on the fringe, and all we know is stuff that's going on here. But let's remember the rules of the road. We actually have two triangles here. Is it possible that these triangles are congruent and these corresponding parts? Well, let's think about it. We know that this side is congruent to this side, and this side is congruent to this side. So we have two corresponding sides of these triangles congruent. What about the angle between? Well, those are, in fact, vertical angles, so we know that they're congruent. And look what I have. I've got side angle side congruent to side angle side. Therefore, these two triangles are congruent by side angle side. Once we know the triangles are congruent, we know that corresponding parts are going to be congruent. That means that the two sides that are opposite the purple angles must be congruent. That means that AB is congruent to DC, and that's exactly what we wanted to prove. We've just proved the theorem. Congratulations.